All right. Well, thank you for having me, everybody. As Wim and Tim think, my name is Derek Smith. I am an Azure Cloud Evangelist. Yes, that is my actual job title at a company called Trace3. So it is literally my job to go out and be in the community talking about Azure, not only internally within my own company, but externally. So I get to spend my day doing what I love the most, and that's interacting with all of you out in the community, talking about all things Azure. Twitter, at Consider Cloud DS, and on LinkedIn, / Consider Cloud with Derek. I may even have a Wim eventually wear a shirt, because we have a fun running joke going. All right, we're going to be talking about Azure Virtual WAN. One of the probably most unknown networking services. And the reason being why I think we need to talk more about this solution is as we move into Azure and we talk about the various services like IaaS, PaaS, and hybrid, connectivity gets to be a bit messy, right? We have multiple connectivity options. Some of our connectivity options have certain limitations, especially when it comes to enterprise scale, which we'll hear a little bit later on. As you scale out an enterprise environment, it can get a bit tricky. And so how do we manage all of those things? How do we ensure that we're keeping track of all of our different connectivity options, our networking within our enterprise scale or all of our various Azure subscriptions? That operational model can be a bit of a challenge. We have different screens we have to go into. Microsoft's done a decent job as of late to start bringing some of that all together, but still it's not quite where I think it needs to be from a true single pane of glass perspective. If you're a previous network engineer, and you can raise your hand, you've heard this phrase, blame the network. Too often the network gets blamed for any number of application related issues, even though it may not actually be the network's fault. And so diagnosing those issues, trying to battle that conceptual thing that a lot of people have in their mind is a bit of a challenge. And we've also seen this software-defined shift, right? We're moving more towards software code, defining everything in that mindset. And especially from a networking perspective, right? We are starting to see a lot of software-defined networking, networking as code, implementing policy controls and network access all through code base. And of course, we can't not talk about networking without security and this shift towards zero trust model, right? Network security is one of the key pillars of zero trust. How do we segment our network? How do we make sure each of those segments is protected and isolated from the other so we can prevent those lateral attacks? And it can be all simplified through one service, and that is Azure Virtual WAN. Microsoft's ultimate vision for Azure Virtual WAN was to bring together networking, security, and routing under what they defined as a SD-WAN as a service solution. It's all cloud-based, and it's offered directly through the Microsoft Fiber backbone that is completely at your disposal throughout the entire world. Now, how they achieve this is through these 5 key unified framework pillars. This is the connectivity. We have a global transit architecture. Remember that it is the Microsoft Global Fiber backbone. We have what's known as a secure virtual hub, where our security comes in. We have a unified centralized routing capability that is dynamic in nature. It is not static. So those of you who hate user-defined routes, I'll show you how with Azure Virtual WAN you can ditch the majority of your user-defined routes, not all of them. And we now have added the capability to integrate network virtual appliances. So if you love Cisco or you love Barracuda or some other solutions, you can actually now integrate those appliances directly into Virtual WAN. So it creates this unified framework for all of those key pillars. Now, when we talk about connectivity, we're talking about obviously our 3 main connectivity options we have within Azure. We have our site-to-site VPN, we have our point-to-site VPN, and our express route. Azure Virtual WAN supports both protocols, IKE v1 as well as IKE v2. There are a number of partnerships that Microsoft has made with third parties to simplify VPN and SD-WAN deployment. So if you have, say, a Palo Alto or a Fortinet or a Cisco, there's actually a nice automated way to deploy VPN connections automatically or in a zero-touch fashion, to where you just literally have to ship a device to your on-prem location, and it'll automatically build the tunnel and establish all of the configuration and policies, right? Managing network through code. Its scale is the highest within any Azure network service, over up to 1,000 connections per region. The virtual network gateway only scales to 30, all right? So significantly more capacity and scale than your traditional virtual network gateway. Some of the new features they've added recently, we have fully qualified to name-based IPsec, as well as we can add in some custom BGP capabilities. Point-to-site VPN, obviously with the pandemic still raging, most of us are still working remotely, working from home. And so Microsoft recognized this early on in the pandemic and greatly enhanced the point-to-site capabilities. So support for IKE version 2, OpenVPN protocol. We have radius authentication capabilities for legacy enterprises. There's built-in traffic management. So no matter where your end users are connecting from, there's a traffic manager that's actually fronting the point-to-site VPN. So we'll automatically route your user to the closest hub and gateway based on performance and geographical location. You can download and integrate with the Azure VPN client on either Windows 10 or Windows 11 or a Mac-based device. Again, it's scale because of the pandemic. You can now get 100,000 users on a single hub with up to 200 gigabits of aggregate throughput. They just recently added custom DNS. So if you are running IaaS DNS in your environment, you can now leverage those DNS servers for domain name resolution. ExpressRoute, it supports encryption. So VPN or site-to-site VPN encryption over ExpressRoute is now capable. You can scale up to 20 gigs of throughput. So you can't necessarily leverage something like ExpressRoute Direct or ExpressRoute Local, but your other ExpressRoute circuits are great additions to the virtual WAN. They recently just added doubled the amount of circuit connections. It used to be limited to 4 per region. You can now scale up to 8, and you can connect with standard circuits. So here's some of those strategic partnerships we talked about. Cisco, Palo Alto, Checkpoint, VMware, iBoss, Zscaler, Barracuda, and many others. Global transit architecture, remember, we can connect anything to anywhere. That is one of the great things about Azure Virtual WAN. I can go from my branch to Azure. I can go branch to branch if I wanted to. I can connect my end users at home to a branch location. I can go from VNet to VNet in a hub and spoke architecture. This is where hub and spoke was born out of within the cloud. I can even go VPN to ExpressRoute. Right. So if I have a branch that's got a VPN and I've got my HQ that's got an express route, I can actually transit both those gateways through virtual WAN. I don't have to set up some fancy routing rule to get there. All the hubs are fully meshed out of the gate. You can turn that feature off, and we'll talk about that a bit later, but it really diminishes the capability. But if you needed that higher level of segmentation, you can turn off the fully meshed hub capability and isolate each region if needed. Now, one of the great things about Virtual WAN is its routing capabilities. It does actually have a dedicated virtual hub router in each hub. It controls the routes between all of the various gateways, so whether it's point-to-site, site-to-site, or express route, and it provides native VNet to VNet transit routing capabilities. There is a 50 gig aggregate limit between virtual networks. Still pretty high unless you're running some pretty heavy data workloads, then you might need to look at maybe a different solution. But for the most part, it's got enough bandwidth to handle VNet to VNet capabilities. You can have up to 500 VNet connections per hub. However, the more hubs you add, then you need to subtracting some of those connections. So just remember, I start out at 500, and then each hub I add, I have to go down in the number of connections because you have to establish those hub-to-hub connectivities. You do have custom route capabilities. You can create your own route tables for virtual networks. There is a route table for your what are deemed branch locations. I call them on-prem, but they are applied in a blank slate. So point to site to site, express route. The route table that is designed for that applies to all three. I cannot individually assign a route table to a point to site gateway and not my site to site or express route. So that is a current limitation, one that I hope Microsoft does eventually remove, but as it stands today, it is treated all the same. You associate connections to the route tables so that they can learn or see those routes in order to route to various different virtual networks or on-prem locations. But you also have the ability to propagate routes from your virtual network connections into those route tables. So much like a dynamic routing protocol such as EIGRP or OSPF dynamically learns how to route to various connections, Virtual WAN can do the same thing with your virtual networks. And you can view all of your effective routes within the route table. Now, from a security perspective, Microsoft did add the Secure Virtual Hub back at Ignite in 2019. This was a new concept of sticking the Azure Firewall directly into the hub because there was a lot of feedback that customers wanted more security at the edge. And up to that date, you had to set up some NVA behind the virtual hub, not actually within it. So people were very concerned about the traffic that was transiting the hub without getting any sort of inspection. So you can now actually inject the Azure Firewall or one of three partners as it stands today, Zscaler, iBoss, or Checkpoint. This is all managed through the Azure Firewall Manager. You can create policies and apply these across multiple virtual hubs. It does work across multiple regions and subscriptions, and it does secure your internet-based traffic, so VNet to internet or branch to internet, as well as private traffic from VNet to branch. The only unsupported scenario when you leverage a virtual hub is hub to hub. That's something they are still currently working on. So if you do route a packet, say from VNet on hub A, and you send it over to a VNet off hub B, that traffic actually does not get inspected between the two secure virtual hubs as it's a current limitation. And finally, one of the newest capabilities is the integration of the network virtual appliance. You can deploy these through the Microsoft Azure Marketplace. Currently, only Barracuda and Cisco have available solutions. So if you are somebody who loves Cisco Viptela, you can actually take your Viptela network virtual appliance and put it directly in the Azure Virtual WAN hub. This allows you to support various SD-WAN scenarios, so your site-to-site, remote user, and express route. You do get the ability of the built-in resiliency of the virtual hub. You don't have to worry about any management. It does integrate with the virtual hub router inside your hub. So all of that routing is still taken care of. And all of the native NVA providers' proprietary features are still available to you. So you get kind of the best of both worlds when leveraging either one of these solutions. So putting it all together, right? So connectivity and security, again, all of the connectivity options are available to you from a virtual WAN perspective, as well as the ability to secure virtual WAN now with the Azure Firewall or a third-party firewall provider of your choosing, as long as it's one of the three. The scale of virtual WAN is truly enterprise. It is considerably higher than the standalone services. 8 express routes per hub, 20 gigabits of aggregate throughput. Point to site, 100,000 users, 200 gigs of aggregate throughput. Our site to site is up to 1,000 branch locations with 20 gigs of aggregate throughput. And then our VNet to VNet, we get 500 VNet connections with 50 gigabits of aggregate throughput. What truly makes virtual WAN unique, we get that express route encryption, right? So we can set up a express route connection and then do a site-to-site VPN tunnel over that express route. Our point to site has a built-in traffic manager, so we can automatically redirect our users to their closest endpoint for better performance and throughput capability. We can automate our site-to-site VPN connections with network policy as code. So depending on the provider we select, whether it be Fortinet, Palo Alto, or many others, we automate in a zero-touch manner to set up all of our site-to-site connections. And again, we have some firewall managed partners, more to be added later. So if we want to choose something other than Azure Firewall, we have that capability. Again, our hubs are fully meshed by default. So any-to-any routing is our default scenario, but we can customize any number of different routing situations with our route tables, as you can see here with my lovely diagram. Pricing for vWAN, it is based on throughput as well as connections. So do keep that in mind. There are what's known as scale units. So the amount of aggregate throughput you need, the more you need, obviously the cost goes up from that perspective, as well as the number of connections that you do have to worry about. If you do add in a firewall, standard firewall charges do apply. So per hour, per gig, all egress charges are obviously charged per Microsoft's rules, but anything inbound is not. Alrighty. Now, when it comes to routing, and this is where I see a lot of organizations struggle the most to really get virtual WAN off the ground. Deploying it is actually pretty easy from a setup perspective. What takes the longest is setting up the various gateways that are available to you inside of your Azure Virtual WAN. So it takes about 30 minutes per gateway, much like a traditional one does. So when I set up a VPN gateway or a point-to-site gateway or an express route gateway, it does take a bit of time. You can only have one virtual hub per region. So once I set up one in, say, West Europe, that's it. I'd have to set up a completely new virtual WAN to set up another hub inside of West Europe. So do keep that in mind. You only get one hub per region, but given its scale, you typically don't need to add any additional ones. Now, when it comes to a routing perspective, in my little scenario here, I've got a couple of on-prem locations. I maybe have a headquarters down here with a branch, and I've got my express route, and maybe I've got some remote users kind of out there in the wild with 2 virtual networks. Now, connections learn routes from the associated route table. And what essentially this means as it relates to scaling up your virtual WAN, when I associate a route table to a connection, those connections then look at that route table and determine, hey, this is where I need to send my packet. So for instance, if I have a default route table with my various on-prem IP addresses, right? I would associate that to my virtual network connections. So as the packet exits my virtual network connection, it'll take a look at that route table. Say it's destined for 192.168.1.5. It'll look and see that, hey, I see that route network is off the site-to-site VPN connection ID. I'm going to forward that to my site-to-site VPN gateway and pass the traffic on down. Similar, if I maybe am a remote user over here and I need to reach a Azure resource that's in my 10.1.0, say 5 up in VNet 1, as I send that traffic up my point-to-site gateway, the route table will take an effect. The virtual hub router will look at it and say, hey, this is destined for my VNet 1 connection. And so it'll go ahead and drop the packet onto my VNet connection and let Microsoft's routing handle that. Now, the connections also have another unique setting within them when it comes to the route table, in that they can propagate routes to the route table. So maybe I associate my route table to another connection, right? I can propagate my networks in that other connection into my route table automatically. So as new networks or new routes become available, right, those can be propagated automatically into my route table. So I don't have to go in there manually to make those updates or those changes. They happen automatically. Now, there is a current rule within Azure Virtual WAN in that the default route table is what allows that any-to-any connectivity. And again, that default route table has to apply to my site-to-site, express route, or point-to-site. However, I can create custom route tables for my virtual networks and my virtual networks only. I cannot create custom ones for my gateway connections. Now, when I do associate a custom route table to my VNet connections, I can configure them how I see fit, right? So maybe I associate a new VNet to my route table for virtual networks, and I want to specify that this little supernet that says, hey, if I want to reach anything that is considered a on-prem location, so to speak, right? I want to send it to this much larger supernet via my VNet 3 connection ID. So now, right, now that I know from a routing perspective that, hey, anything destined, right, for 192.168.00/16, if I'm over here in VNet 3, I can simply drop it on my VNet 3 connection ID and get it routed out to my virtual hub router and onto my on-prem locations. Now, that's not to say that your route tables don't have the ability to add in a static route. You absolutely can. But typically, this is only something that you would do in the instance of if you have a very specific hop that you want traffic to take, say a third-party NBA sitting behind maybe a load balancer or an application gateway or something of that nature. So if there's a very specific hop that I need my traffic to take, I can actually still add in a custom route and force traffic through that device if needed. Now, from a zero trust network security perspective, it's all about segmentation and isolation. Maybe I do not want certain VNets talking to each other because there are sensitive workloads in each. So I want to make sure that I'm isolating them from each other in case a VNet or a workload inside that VNet gets compromised. I need to make sure that my other VNet is protected. But I don't want to restrict my on-prem users from still being able to access those workloads from a productivity perspective. So in this custom use case, we want to make sure that we create a custom route table as well as leverage our default route table. Our default route table is still going to have our site-to-site and express route connections. However, you'll notice that in our custom route table, we're only going to add our on-prem locations as something to route to. What this does is it doesn't allow that VNet transitive routing, effectively isolating them from each other. Now, our on-prem default route table will still get both routes. So whether I am at my headquarters or I'm leveraging the express route connection, I can reach either VNet 1 or VNet 2. However, from a VNet to VNet perspective, I'm being denied. It will not route packets between the two, but I can still reach my on-prem resources if needed, effectively isolating them from each other. Now, in what another common use case is maybe I do have a shared services VNet. So we're going to bring back our third virtual network. Maybe this VNet has another connectivity to another on-prem location. Some other shared services like DNS or Windows AD. All of that, we want to make sure that our other virtual networks as well as our other on-prem locations can leverage those capabilities. So we're going to bring back our trusty default route table. The default route table will get our VNet 3 connection as well as its own on-prem connections. We'll still keep VNet 1 and VNet 2 in there. However, when we come to our custom route table for our virtual networks, we're going to make sure we add in that next hop under the VNet 3 connection ID. Because we do have that specific device we need to route through. So under our VNet 3 connection, we're actually going to drill into that further and add in a static route, specifically making that next hop 10.3.0.5. So everything's going to pass directly through that particular IP to get access to our shared services. So something like maybe a proxy or an application gateway, all available to us. Now, expanding on that isolation VNet scenario, maybe I've got multiple regions to worry about. So now out instead of West Europe, now I've got to think about, let's say, what Eastern US, right? So I've got something in West Europe and Eastern US. How do I isolate those, right? And this is where we can start thinking of things as in, if any security folks are out there, right? Red team, blue team. So I start thinking about it in those instances, right? So I have certain virtual networks that I designate a blue team, and then I have certain virtual networks. In my case, I designated them an orange team. So in this case, I want to make sure my branches can still talk to each other. My blue VNets can still talk to the branches. My orange VNets can still talk to any of my branches, but I only want my blue VNets that are running similar workloads to be able to talk to each other, and I only want my orange VNets that have similar workloads talking to each other. And this is where something like the label capability within Azure Virtual WAN comes in handy. Now, labels are a way to propagate routes from two different route tables to each other. So by default, when you first create Virtual WAN, the label known as default is created automatically and is assigned to the default route table. So anything with the label of default will actually get the same routes propagated to each other. So when I have two different regions or two different hubs, and I need to make sure that they're all staying in sync with the same route concepts that the other is, this is where labeling comes into effect. I can propagate all of my route connections to the label of default. So anything that is assigned with that label then gets all of the same routing routes available to it. So if you notice now, my on-prem connections can both see each other with their routes. So 192.168.1.2 can see .3 and .4 over in the other region, and vice versa. Now, for my blue VNets and for my orange VNets, I'm going to create two more labels, one for blue, one for orange. Under my blue label, I'm going to ensure that my on-prem locations are still there. Because I still want my blue VNets to be able to talk to on-prem so my end users can get access to those workloads. However, I'm only going to put in the routes for my two blue VNets. So in my case, I have VNet 1 and VNet 3. So that way, over in VNet 3, right, it can see VNet 1 per the blue label because I'm assigning that label to my VNet 1 connection ID as well. So that route table gets the label blue. And subsequently over in my orange scenario, same thing. My VNet 2 and my VNet 4 are going to be assigned to the label of orange so that routes learned by either one of those VNet connections will be propagated into my label of orange so they can stay up to date. However, you notice now they cannot talk to either of my blue VNets in either region. And then my on-prems will get the VNet connection IDs for all workloads, again, ensuring my users can reach any workload that's required to perform their job function. Now, from an any-to-any perspective, say I do not need to institute any sort of zero trust network segmentation, and I just want to wild west my network. You just have to leverage your default route table. Again, fully meshed any-to-any is the default setting. And this allows you to propagate to whatever any network. Now, what if we decide to throw in an Azure Firewall, right? Give us that edge security capability. Well, just remember, we want to make sure that we're forcing any VNet destined internet VNet traffic destined for the internet. We want to make sure that goes out our Azure Firewall. We want to make sure any of our branch traffic transit out our Azure Firewall, right? Saving us our on-prem costs from maintaining a firewall on-prem. And then any private traffic, either VNet to VNet or branch to branch, we want to make sure it goes directly. What we will do from a route table perspective is we'll still maintain our default route table. So you see all of my connection IDs are added to this route table. Now, what I will do, however, is I'm going to add in a static route into my route table, quad 0. So if it is not private, if it's not destined for another piece of resource or infrastructure within my environment, I want it to exit the Azure Firewall to be inspected. Both route tables will get that route because they have the label of default, so it will propagate the quad 0 in both hubs. Now, the good news is you're probably looking at this and saying, well, what happens if something from VNet 3 is going out the quad 0? Because the local route table, right, local hub route table has this quad 0, it will exit the local Azure Firewall. It will not transit between the two hubs to exit a different firewall. So you don't have to worry about any sort of egress over to a different firewall. Now, if you choose not to use the Azure Firewall in the hub and you still want to leverage something like a network virtual appliance because maybe your preferred vendor is still not available, this custom use case is still supported from a virtual WAN perspective. What typically happens is you will designate a VNet that is connected to your virtual WAN to act as your shared services VNet, kind of like what we saw earlier with VNet 3. Now, typically what happens in these scenarios is I have a load balancer, or now the network load balancer fronting a HA pair of network virtual appliance firewalls. So my default route tables will still get their standard connection IDs for both regions. However, what I will do from a VNet 2 and a VNet 4 perspective is I'm going to add in a static route for those specific private IPs that are fronted by the load balancer. So in our case, we have 10.2.0.5 and 10.4.0.5. And what ultimately happens in a lot of these scenarios is there are other tertiary VNets that are connected to our shared services VNet. In our earlier use case, we had a tertiary on-prem location. So in this case, we are adding in a tertiary VNet, a couple of them. Now, unfortunately, this is one scenario where you will have to add in user-defined routing to connect, to force traffic from our tertiary VNets to go to VNet 2. Virtual WAN cannot see these, so therefore we cannot apply our route table to facilitate dynamic routing. So again, you're going to ensure those UDRs from the indirect spokes to the NBA shared VNet. You're going to ensure that static route goes to the NBA connection. So again, VNet 2 and VNet 4 connections will get the static route for their respective network virtual appliance. And you'll add that in on our route table. So where you see 10.2 and 10.4, you'll add in that next hop static entry. And the traffic patterns then look like so. So our tertiary VNets can communicate with each other. Excuse me. When they route out to the internet, they'll go through the network virtual appliance firewall that's in that shared service VNet. But we'll still be able to communicate with our on-prem locations. So if I'm sending traffic from my on-prem express route here, I can still reach my tertiary VNet. It'll just get picked up in routing by that network virtual appliance and forwarded on to the tertiary VNets. Here's a good example of what a route table would look like when I've set up a virtual hub instance within my Azure environment. So when you go into your virtual WAN environment and select your virtual hub, under connectivity, you'll see this little routing icon. It's a purple globe, and you'll see the two default tables that get created automatically. That is our default route table and our none route table. And I'll tell you what none means here in a minute. But if you would like to create a custom route table, the little icon up there at the top, you can create a route table. When you create a route table, you need to set up a couple of different things. You can give it an instance name. That name just has to be unique inside of Virtual WAN. It does not need to be unique globally or even in the subscription. It just has to be unique within your Virtual WAN instance. In this instance, I'm going to set up a static route to the Azure Firewall. So I have my VNet connection ID. So you can see here, I've given the route name a name of test1. The destination type is a CIDR notation, and I've defined the CIDR notation as 10.0.1.0/24. And my next hop is that VNet connection ID that I've set up. So when I've connected my virtual hub to my virtual network, its peering is done exactly the same as you would peer a VNet to VNet. Now you'll notice right here on the right-hand side, under Next Hop IP, I have the option to configure that static hop. So I would go ahead and select Configure. And I can add in my static entry for the firewall and providing that specific IP for the next hop. Once I've done that, I want to go in and create my labels. A route table can have more than one label. So if there's a number of different route tables that you need to share routes between, you can add multiple labels to your route table. Don't always necessarily recommend it, but I've seen one or two instances where it has been something that's been required from a routing perspective. So you can see here, I just added in a test label. Now, the next two pages have to do with the associations and propagations. Now, remember when I associate a route table to a virtual network connection, I am specifying that these connections will learn routes from this route table. All your connections are always associated with at least a single route table. Okay, so you have to associate at least one. Excuse me. Once I've done the association, I would then move into my propagation. Again, we're selecting the connections that I want this route table to learn routes from. And this is where we can include our branches, our on-prem locations. So if I want my on-prem locations to propagate routes into a route table that they've learned, I can absolutely do that. So maybe I add more networks from my VPN or my express route, right? And I want to make sure I share that to my route tables without having to manually go do it. I can. That's what the ability of propagation gives us. Connections can propagate to multiple route tables. I do not have to do just one. I'm allowed to propagate to as many route tables as I see fit. Just remember that our branch connections always have to propagate to the same set of route tables. Whoever's, thank you. Now, once I've completed my route table, I obviously want to make sure that my routing is set up the way I want it to. And we absolutely can go do this. I can go into my effective routes, as you see here, and I can view all of the effective routes for the route table that I've just configured or any other route table that I have access to. So you can notice here that I can see what my next hop type is, where it's going to go, and what its origin is, right? So if it's coming from the default route table, maybe the origin's coming from my gateway route table, right, for an express route gateway or VPN gateway, or maybe it's coming from another hub. So I have an East Asia hub, right? So maybe I need to transit over to East US, or I'm doing VNet to VNet. So you would see East Asia to East Asia. If you do have BGP configured, you can also see your AS path information as well. So to make sure that things are routing across the correct autonomous system path. All right, to summarize, as it relates to routing, remember that site-to-site, point-to-site, and express route connections are all considered branch spokes. So they will get the default route table associated to them, and they always must propagate to the same set of route tables. You cannot pick and choose site-to-site, point-to-site, or express route, which different set. They all have to propagate to the same. This is a limitation. Again, something we're hoping Microsoft fixes here in the near future. Custom route tables are only supported for virtual networks, not for our branch locations. Again, it's a limitation Microsoft is aware of and hopefully addressing here again in the future. Connections associate to a route table to learn routes from that table, and then connections propagate to a route table. All right, so the route table learns from those connections. So it is a two-way trust between the route table and our connections. Again, as general routing rules within Azure go, the more specific route always wins. So within my route table, if I create, say, a supernet, right, using a /16, and maybe somewhere further down, I have a more specific route for that network, that more specific route is going to win. There's no priority, there's no order. It evaluates the whole table and picks the most specific route. You can set up a static route to be a next hop via either Azure Firewall or some NVA device that's fronted by a load balancer or the NVA itself. And that is done via the VNet connection ID. So you need to specify the VNet connection that your NVA is in. And then I go in and configure a static route as a next hop. And I put in the specific private IP that I intend to be the next hop for that traffic. Azure Firewall, quad 0 route, and you can go in and select the dropdown. It is available in there. You specify specifically that you're looking for the Azure Firewall, and then Microsoft takes care of that routing for you on the back end. Again, we can view our effective routes on those route tables to ensure that our routing is configured the way we want it to. And it also serves as a troubleshooting device. So if something is not routing the way it should be, we can go in and check and make sure that our route tables are set up correctly. Now, I did mention I talk about what the none table is. It is the connections that go to a black hole. So if you do not want your VNet to propagate to a route table, you propagate it to none, right? So I can choose my connection to propagate to the none route table. It will never propagate routes to any other route table within your Azure Virtual LAN instance. Same thing with the label of none. If I want to ensure that I keep a virtual network completely isolated, even more so than my scenarios that I showed, I can leverage the none route table and isolate that virtual network completely by associating it to the none label. Next steps, if this piques your interest and you want to learn more about Azure Virtual WAN or even spin up your own POC environment, I encourage you to spin up your own lab. I have a very useful GitHub available for you guys to go check out. And the address is posted there on my screen, https GitHub Stefan Lavamo, VWAN Playground /3/VWAN Playground V2. These are an awesome collection of virtual WAN bicep scripts. So you can deploy with bicep your own virtual WAN playground and play around. It does deploy the Secure Hub option. So you will get an Azure Firewall, a couple of VMs set up to test connectivity, as well as site-to-site VPN. And you can see how to help you view virtual WAN natively. It doesn't cost too much per day. However, I do caution not to leave it up for too long. Otherwise, the cost will get decently high. Your second action item, Virtual WAN is now starting to find its way more into the official Microsoft learning paths for various certifications. at the time that I wrote this, it was available in the Solution Architect AZ303. It still is, but as we've all heard, the AZ303 is going to retire as of March 31st, 2022. So that content will be shifting over to the AZ104 or the admin exam. More specifically now, though, I would encourage you to go into the Azure Network Engineer Associate or the AZ700 exam, as we now have a dedicated network engineer learning path. So there's a much more in-depth learning material within the AZ700 around Azure Virtual WAN. So I encourage you to check that out as well. And just to summarize, remember that Azure Virtual WAN provides a ubiquitous connectivity, routing, and security in a unified framework across the globe. All right. Thank you, everybody, for tuning in. I appreciate this. I think I saw a couple of questions popping up, so I can take those as needed here.
So Rob, maybe you can unmute and ask your question if you want.
Thanks. Yeah, Derek, I just wondered if you had any advice regarding brownfield environments where customers have been interested in going into Virtual WAN, but weren't quite sure how to tackle it.
So there's actually some specific migration scenarios for customers that maybe are already leveraging Virtual Network Gateway to transition over to Virtual WAN because they've either hit a limitation or they just need kind of that more enterprise scale connectivity. So essentially what you would do is you would still spin up your own Virtual WAN instance and kind of build that out on the side and then slowly change your connectivity from the hub network that you've set up in a brownfield environment to your Virtual WAN. Test that connectivity and make sure that it's routing and it's reaching all of the stuff that it needs to. And then obviously you would spin down your environment. I will get you the link to that documentation, but it's a pretty prescriptive process on how to transition and migrate out of virtual network gateways into a Virtual WAN environment.
That's great. Thank you.